Hi everyone, my name is Rena, and this is a video about the universe and what I know so far. So it's just a theory, it's just something I'm putting out for like thought experiment type idea. It's including things about the universe and how the universe functions, how we're able to stay in something that is organized yet seems really chaotic. So I want to mostly talk about how the universe is expanding. Sorry, that's my bird. I mostly want to talk about how the universe is expanding and how it's expanding into nothingness while also having material to expand, which seems like a contradiction, seeing as you would have to expand into something. You couldn't expand into nothing, because if nothing's there, how are we expanding into it? So I'm just going to pause the video for when I'm writing on the board, because I don't think you guys want to sit here and watch me write on the board as I do. So I'll get started. So the first thing I want to talk about is Thales, and we'll get to that right now. Okay, so the first person we're starting off with is Thales. Thales was an ancient Greek philosopher that pretty much as we know it started the narrative of philosophy from at least as far as the Greeks go. And so Thales in particular thought that everything was made up of water. He was someone that believed that we had one element that made up the entire universe and that element was made up and comprised of water. We're not really worried about that part. What we are worried about, or more so inquiring about, is the second rule. So Thales made these axioms, and the axioms are these kind of rules, as we'll discuss. Rule number one was things are not always as they appear. So when Thales thinks that the whole universe is made up of water, he believes in entailment, which we can talk about another time. But it basically means that while everything's made up of water in the universe, we all appear different. So while this looks like a glass bottle, in reality, it is made up of some type of moisture. But like I said, we won't worry about that now. We can talk about that another time. So we're worried about number two. Number two, he says, from nothing we get nothing, or from something we get something, which means, as it pretty plainly says, you can't get something from nothing. So if for example, babies, if we wanted to have a baby, we can't just get that from nothing. It doesn't just come out of nowhere. It's not created like ex nihilo, like from nothing out of nowhere in thin air. It's created from something, which is sperm and egg coming together to make a baby. So what that means is everything in the universe, from nothing, we can't just get a drink, we have to comprise it, synthesize it, and from something, we get something. So that's what I'm mostly inspiring the thought off of. Sorry, that's my bird. But yes, so while we have this in mind, from nothing, we get nothing, or from something, we get something, which means if you know about just the little parts of the universe and how we understand it so far, it's said, not colloquially, but it's said kind of off the cuff that we are expanding into nothingness. So let's get into that. Okay, so as the universe is that we know so far, we have this picture above. So what happens is the universe, at least our galaxy. Okay, so where we'll start with is our Milky Way galaxy. Now, when we know, I don't know if you guys know this or not, but from what we know so far, understand so far about our galaxy at least, is that we're chasing the sun. So when you look at our plethora of, well, not plethora, but like the planets that we talk about, we do have others that go farther out, but we're just gonna talk about the main solar system planets. So as we know, we're chasing the sun, right? So if you guys didn't know this, then welcome. But like if you did, then you know we're chasing the sun. So while the sun is out front, you have this system of planets that is constantly chasing it. So think of like the lead of a spear. So while we are in our entire universe, you have the sun that is kind of like the leader of our pack, because we have to chase it for light and also its gravitational pull, and obviously life comes from there. So when we're chasing the sun, it's like flying through the universe, and all of these planets are think of like a suction. All of the planets are chasing behind it. So the question is, if we have all of these galaxies around us, all of these planetary systems, we have, let's say, the Andromeda galaxy system that we hear about all the time, and we have, I'm sure, a billion of Kepler, might be another one. I know there's Kepler planets. I don't know if that has to do with the solar system or not, but we have all these different solar systems that are around us. Now, something we know about atoms is actually pretty interesting. What we know about atoms is that they tend to not collide. So we have to think that there is some kind of organization to the universe, whether how minute or large it is, we're not understanding it obviously yet, but there is some kind of organization, it seems, to it all. Because if atoms don't collide into each other, how is it in this like bowl or bag or however you want to think of the universe, how is it that none of these are colliding into each other? We do have asteroids and meteors. That's not what we're talking about, though. We're talking about all these solar systems. And if they're going in every which direction and there's no rhyme or reason or no organization, rather, then how is it that we're unable to collide into each other? It would have to seem that there's some kind of organization to it all. It also seems that when we use a telescope and look at something far away 2 years ago and check it out 20 years from now, and we have those time frames, it seems that the distance stays at a steady rate of distance. It doesn't get closer, it doesn't smash into something else. It seems that everything stays relatively separate. So that would insinuate, obviously, that we're expanding, right? Which means that as much as we have a center of something, we are expanding at an even rate out from each other. But now here's where it gets interesting. So while we are expanding out away from each other, how is it that we're expanding into nothing? That doesn't seem to make sense, because if there's nothing, how are we able to expand into it? So here's the second part. So now the part that we have to talk about has to do with the spreading, right? So they're all spreading out at this seemingly even rate. However, there's a hiccup in it all, because we do have something that we learned recently. Well, recent to me, but so our galaxy is expanding, right? And we're expanding, everything around us is expanding, but we were able to find a galaxy system that is far away that seems to be close to where we think the Big Bang happened. So let's just preface this also saying that this theory is working off the essence of the Big Bang. So with that, we'll move on to the second part. So we're dealing with the Big Bang expansion, but also one of the oldest galaxies that we've ever found that was born around the Big Bang is expanding at a slower rate somehow. How is that the case? The primary question is, is it that we are expanding at a certain rate? Granted, we're born later, and yet that is born soonest to the Big Bang, or at least sooner than us, is expanding at a slower rate constantly. How do you have two time differentiations that exist in the same universe? And that would also give a hint to like gravitational poles and things like that, but let's get into it. So a couple things to keep in mind with this theory too are, one, positive energy moves outwards. And what we mean by that is I'm referencing Einstein's theory of general relativity. And what his theory of general relativity states is regions of space with positive energy pushes outwards. As space expands, it releases stored up gravitational potential energy, which converts into intrinsic energy that fills the newly created volume. So what I'm saying is also, like it says, positive energy pushes outwards, which will push things in motion away from it. On top of that, we have dark matter and empty space. So what we're talking about is the confines around it, which is dark matter and empty space. And when it comes into contact with that active energy and matter, it then is able to become a newly inhabited space. So yes, as I said, dark matter and energy in space were always there, but upon interaction with active energy and matter, they become transitioned into occupied space with now observable features. That's what I'm thinking. And I was thinking, like, what if dark space only appears to look like we're like expanding into it, when in reality, it might be something else. But that's not my main point. So as far as the universe, I'm thinking this. So here is going to be, for example, the beginning, or the genesis, we'll say, of the universe, which I'm going to also say is the pinpoint of the Big Bang. So pinpoint of Big Bang. So while that's the beginning of the Big Bang, let's say we're out here and that this is the Milky Way. So my theory is that it's sort of suctioning us in. So what that can do is that's also allowing for us to have speed differentiations as well. So when you're closer to the pinpoint, the genesis of it, it seems to be pulling us in towards it, and it would move theoretically at a slower rate from out here and move in to the middle. And I'll explain a little bit of that later. So if you have any questions bubbling, write it down. and definitely comment it to me later if I don't satisfy the inquisition, or the inquiring rather, of it later. So this is my main theory, is I'm saying that it's kind of like a whirlpool. So we're in a whirlpool, and why I thought this theory made sense is because it keeps our relations to other galaxies at the same rate. So it would mean that there's still this energy that's pulling us towards something, but that it is also keeping us in line with everyone else. So while it's pulling us and giving us the motion necessary to attract the galaxies and planets, it's also keeping everyone at an equal distance so that things aren't colliding into each other, if that makes sense. And also, how I'm going to make this make sense too is I'm going to give you guys a picture of the whole thing, because this piece alone leaves a lot to question, but I'm going to put it in the entire thing that will show you the exact theory that I'm encapsulating or synthesizing. So here's where things get kind of crazy, but in a good way. So what I'm going to do is I call this, for lack of a better term, like my suction cup theory. I'm going to come up with a better name, but this is what it looks like. So while we are here and keeping that distance to each other so that we don't smash into one another, because that would be just chaos. So we're keeping our distance like relative to each other, and we're allowed to chase the sun still. So we're still chasing our sun. We're still in this formation while being in proximity to everyone and keeping a relative distance. Now, what I'm going to show you is how I can account for the speed variations. Because we have, like I said, one of the oldest galaxies that we know to exist now that is expanding at a slower rate, which doesn't seem to make sense if everything's speeding up and we have this positive energy that's expanding. But it does make sense in this scenario. So just with me for just a moment, and let's say that the Big Bang started here. And here's our pinpoint. Now, as we know, things blast. If we're saying Big Bang, it's not like, here we go. It's more like, and here's the freaking universe, you know? So if it blasts off from the center, picture a bag. Picture a bag that is empty. And you have the Big Bang in the middle, and you have a bag that can expand, but isn't right now. So this isn't here. Then upon the Big Bang expanding, it boom, blasts off and turns into all these, like all directions too, you know, and like becomes all these galaxies and planets and all this matter that has this leftover gravitational potential and energy that is, you know, making everything stick over millions, billions, trillions of years, whatever. So once it blasts off and it's spread out into everywhere, now it's in this bag. Think of it as a bungee. So think of it as it needs to collapse back in on itself. So now that you've spread it out into nothingness, it was never nothingness. It was something that was unfilled. It's something in flux, if you will, like anything that can expand, a sock or, you know, a bag, or like anything that has the potential to expand in energy, a balloon. So you blast off, you have this pressure that's going to need to collapse back in because you just rubber band it out. So now you have all of these galaxies and things like that, and then you have it come back in to the genesis, or the beginning of it rather. I keep calling it the genesis, whatever. But so while it blasts out, you have all of these planets, all of these galaxies that are all over the place and have their own little freaking systems that are like starting up. And then you have this gravity pulling it back in onto itself. So all of these planets will look like they're speeding up. Like they're also keeping a distance, but they're speeding up and they're moving fast because they're being pulled back into the center, which also, in my opinion, for what I know right now, would explain why this one is moving slower. This is one of the old, we'll say this one for the sake of argument was one of the oldest galaxies, the one that we discovered recently, and that is moving and expanding at a slower rate. We're going to say that it is because it's in the time variation, if we believe in time or the construct of time, this time is moving slower because it's by the base already. It's by the origin. So it's not, its pull wouldn't be that severe. We're out here, it's so far from the origin that it needs to collapse back in on itself. Sorry, that was a little violent, but it needs to collapse back in on itself. So it's going to pull it at potentially a faster rate. So that is my idea of what the universe is doing, and that would account for the gravity, the gravitational pull, and the speed. So yeah, that's my main theory as to what's happening in the universe. I think that it accounts for the acceleration, for the slowdown. However, I don't have a firm belief as to whether or not this rubber bands back. So if this was something that, because again, I'm not entirely solid on the dimensions of anything yet, or would I be dareful enough to say that I know? But we can't tell, or I can't tell, the committee of me can't tell if this will rubber band back down. Does this collapse in on itself and start a new Big Bang? Does it collapse and rubber band down and have something go on down here where it kind of yo-yos back to a kind of flat line, or not flat line, but like to a flatness, or like a oneness, to a ball of nothing again, only to be Big Banged again? Or is it going to collapse and Big Bang back out? All I know is that this part accounts for how I know the universe to exist so far. So let me know what you think. I think it's awesome and cool, and I like talking about it anyway, so I would love to hear what everyone thinks. And I'm gonna call this Rena's suction cup theory. I'm gonna change the name, okay? Don't quote me on that, but for now, it's Rena's suction cup theory of the universe. But yeah, if you have any questions too about it, please let me know, because I would love talking about this. And like I said, it would say why everything is in a proximal distance and keeping that space without smashing into each other, and also why we're collapsing in on each other. Thank you.